In this video, we're going to look at topic 21, example 1, where we understand an inequality in two variables. So in part A, what is the solution of the inequality? Y is less than or equal to x minus 1. And then they give us a statement here that tells us the inequality y is less than or equal to x minus 1 is an example of a linear inequality in two variables. It has the same form as a linear equation, but uses an inequality symbol. The solution of a linear inequality in two variables is all ordered pairs x, y that make the inequality true. Okay, so to solve these, there's really four things you want to look at. And what you want to start with is your first one. So you're going to start with the y-intercept. Actually, let's not say start. Let's say plot the y-intercept. All right, and in this example, we have y is less than or equal to x minus 1. So our y-intercept is negative 1. Okay, so I want to plot that point where at the y-axis at the point negative 1. The second thing we're going to do is you're going to plot a second point using the slope. And in this specific problem, our slope is really just, sorry about that, that wasn't supposed to happen. Our slope is just 1. All right, so the slope in this case, we have a rise and a run. And here it's 1 over 1. So we're going to go from the y-intercept to our second point. We're going to go up 1, over 1, and plot our point right there. All right, step 3, we're going to, we'll say draw a line. And this is one of the first newer steps, different than what we have done before. So in this case, if you have greater than or less than, it is a dotted line. If it's greater than or equal to or less than equal to, it is a solid line. Okay, so it's important to note that. And in this case, we have greater than or equal to. So for this one, when we draw a line, it's going to be a solid line, right? Because it is less than or equal to. All right, so make sure you're careful with whether you use a solid or dotted line. But I'm going to connect these 2 points using a solid line. Something that looks like that. And the alignment seems to be off, so I apologize for the extra scribbles. So at step 3, we draw a line. Now we've done this before. We've plotted lines using equations. So this looks quite like an equation that we've graphed before. The main difference now is that we're going to be shading regions. So step 4, we're going to shade, we'll say shade the appropriate region. And something like greater than or greater than equal to is above, and less than or less than or equal to, actually let's put the y, so y has to be on the left in this case to follow this rule. And if y is less than or y is less than or equal to, it would be below. Now what we mean by that is you look at your line and you would draw yourself 2 arrows, or 1 arrow, whatever you want to do, however you want to figure this out. But if I'm on this line and I draw an arrow going that way, in that direction, that arrow is pointing up. So that's the region that's above. If I draw an arrow this way, that's not supposed to happen. If I draw an arrow going down this way, that's going down, so that would be below. So in this case, we have a less than problem. All right, so we have y is less than, so we would want to go below. So I would just shade everything that is below that line. So in this case, it would be this whole region here. And then we could just fill all that in. The screen is really not cooperating with me today. I apologize for that. So let's do that a little bit better. And then we'd have our shaded region. And anything in that shaded region is a solution. Okay, and I'll get to the actual line itself in a second. But within this shaded region, if you were to take any of these points here, pick any of them, and plug them into your inequality, it would remain true. Okay, so the solution to this inequality is that green shaded region, and in this case, that solid line, but I'll get into that bit more specifics in a moment. In part B, we're going to look to be doing the same thing. So this time they say, what is the solution of the inequality y is greater than x minus 1? So we're still going to start with the y-intercept. So that is -1. It's the same in this case. They didn't change it. So we plot the -1. Step 2, we're going to plot a second point using a slope. Again, that's rise over run. And the slope in this problem is still 1 over 1. They haven't changed it, right? So we have a slope of 1 over 1. So we're looking at all that there. Okay, so from our point, we'd go up 1 over 1, plot that second point. Now step 3, we want to be careful here. They tell us to draw a line. If it's greater than or less than, it is a dotted line. And in this case, that is what is true. So we have a greater than symbol with no equals. So when we draw this line, it is going to be a dotted line. Had it been greater than equal to or less than equal to, it would have been a solid line. All right, so when I connect these points, I'm going to draw a dotted line like this. I'm not going to have my arrows. And then the fourth step, we're going to shade the appropriate region. So y is greater than or y is greater than equal to, that would be above. And if y is less than or y is less than or equal to, that would be below. Okay, think arrows up, arrows down. So here we have a greater than problem. So we're going to shade above. So if I draw an arrow, that one is above. So we shade this whole region in this case. Just going to be actually the opposite of the previous problem, really. So just shade this in as best we can. And so for these problems, the problems are done pretty much the same way, whether it's greater than or less than, you're just shading opposite sides. However, you have to watch out for the solid and dotted line. In the example in part A, all of your solutions, so even the solutions along the line, are solutions to your inequality, because that's what makes it equal. However, if you look at the dotted line in part B, points that are right on the dotted line are not solutions of your inequality. Okay, you want to think of the dotted line more as a boundary that is not included. Or it's almost like a wall, right? You can't kind of go on top of the wall. You can kind of just go up to the wall. So the points along a dotted line are not solutions. Okay, keep that in mind. Solid line, the points along the solid line are solutions. Points along the dotted line are not solutions.